Hello, my name is Michael Kaler, and I am the lab manager of the IAMM Diffraction facility located at the University of Tennessee, Knoxville. If you would like for us to test some samples for you, please just send me an email at this address and we can discuss the cost. These are all the different things we need for filling a glass capillary. We have our sieve, which is great for separating out larger particles and also separating the smaller particles that might have agglomerated. These are our glass capillaries. For this video, we will be using capillaries with a 1 millimeter outside diameter, 80 millimeter length, and 10 micron wall thickness. This is our Lab 6 or lanthanum hexaboride powder from NIST. And this is a capillary buoy from Huber. This is a bit expensive, but it makes filling glass capillaries much easier. It is optional, but I do recommend it. Normally, I like to put down a large chem wipe first to keep the area clean, a bigger piece of weighing paper, and then a smaller piece of weighing paper. First, we will put some of our powder into our sieve. I'll put that right on top of the small weighing paper. I'll scoop out a little bit. That looks like a good amount of powder. Next, I will fold the paper a little bit to get the powder to bunch up towards the center. You don't want to press the powder because it will then stick together, which would defeat one purpose of using the sieve. That's good enough. Next, I will grab a capillary. I will pop the top off there. There is a little bit of styrofoam on top, so take that off with a pair of tweezers, and then grab one of the capillaries. We'll put the styrofoam back on top, cap it, and put it off to the side. As I said before, these capillaries are very thin-walled. They are 10 microns. Especially if you put any force down here, it is very easy to break them. I broke my fair share when I first started with capillaries and still do from time to time. Normally, I like to handle it from up here, but for this step, I will gently hold it from the bottom. I'll then pick up the paper and do my best to scoop some of the powder into the wider top part of the capillary. Now I've got some powder in there. I'll start off by tapping a little bit to get some of the top stuff to start dropping down. Usually this doesn't get it all the way down very easily. You can see it is spaced out in parts. What I'll do next is grab the capillary buoy and show you how easy it is to get that powder to go down the capillary using this tool. I will insert the capillary into the center hole. You just have to be careful because you can break your capillary doing this. Don't apply a lot of pressure. I'll push that all the way down, and we see that we still have our two sections of powder here. I'll turn the knob on the side, and I'll keep turning the knob, and you'll start to see it shake. If I continue turning the knob more, the frequency of the vibration will increase to the point where you can't see it moving anymore. I'll keep going until I find a frequency that gets the powder to drop. I'm not changing it anymore now. The powder has already dropped quite a bit of the way. Let me increase the frequency a little bit more, then decrease it. Sometimes it helps to go back and forth a little bit on the frequency. It looks like the powder has dropped all the way. I'll turn it off, put that out of the way, remove my capillary, and then try to scoop up a little more powder. This powder is already sticking together a little bit, so that makes it a bit more challenging. I think I've got some in there. Some of it is stuck on the outside. I'll tap it again just lightly. I don't want to break anything. I'll then go back to the capillary boy. Turn it on, turn up the frequency. And there we go. I'm going to keep doing this until the tube is as full as I need it. I'll take this out and you'll see about how full I've filled this one. I don't know if you need to have it this full for your situation, but this works well for me. The next step will be to seal the capillary, but I do want to mention one thing first. Not all powders behave as nicely as the NIST Lab 6 did. For example, the capillary on the screen now contains NIST silicon powder that tends to stick to the capillary walls, making it difficult to see if the capillary is full or not. If you shine a light on the tube, you get a much better look at how filled it is. As you can see, it is only partially filled now. However, as soon as I remove the light from it, the capillary appears to be completely filled. Now that we have covered this situation, let's proceed to sealing the capillary. These capillaries can easily be sealed with a simple lighter. As soon as the capillary touches the flame and begins to melt, I gently twist both ends, and that's it. Just make sure you don't twist the tube before it begins melting, otherwise you might break the tube. If you have any questions, please leave them in the comment section below. Otherwise, Benjamin and I thank you for watching, and we hope you have a great day.